Okay, I thought I'd spend a little bit of time today going over the properties of logarithms. There's just three of them that I really want to talk about. And the first one just says this. It's called the product property. So product property, and it's really simple. It just says this, that if we have log base A of m times n, well, we can rewrite that as log base A of m plus log base A of n. And this should kind of remind you of your properties of logarithms. So this is the product property. The second one is called the quotient property. If you think about the rules of exponents, I think that might come to you. So the quotient property says something very similar. It says that log base A of m over n is the argument will give us log base A of m, A of m minus log base A of n. The next one is called the power property, and it's really important because it helps us to move logarithms around a little bit and get to a solution. So it looked like this, and this is the power property. Power property. The power property just says this, that if we have log base A of m may be raised to the exponential value of r, that we can rewrite that as r log base A of m. And if you can see what happens is we take the logarithm, take the exponential value and we roll it back and put it back to kind of like a coefficient value. All right, so let's try a couple of these. Let's just try this one. Let's try to use the sum of logs here. So what if I gave you this? What if we took log base A? The reason I use log base A is because log base anything, if it's allowed to be a logarithm, this rule will apply. All right, look like this. So this is called expanding. So if we use these rules to expand, then it might look like this, right? We'll get, see if you can see it here, right? Get log base A of x, right? This thing is being multiplied, isn't it? It's being multiplied, so that gives us this rule, this first rule up here, right? It's being multiplied here, it gives us the plus there, right? So I'm going to say, okay, I have this. This multiplication sign tells me I'm going to get a plus sign here. Then I'm going to take my log base A again, so log base A. And now, if you look, right, we have this. We have square root of x squared plus 1, right? So you could leave it that way. However, if you can see this, remember that radicals are the same as rational exponents. So if we say that we have the square root of x, the square root of some value, we have x to the 1/2 power as its equivalent rational exponent, replacing a radical. So I'm going to go ahead and do that. Put these in here, right? And then hopefully you can see that using this power property right here, I'm using this rule here, I'm going to be able to take this and roll it back to here. So the answer should come out right, log base A of x, right? Should get log base A of x plus 1/2 log base A of x squared plus 1. And where did this square root go? Remember, we turned it into a rational exponent and we rolled it back using the third rule. All right? Look, I hope this is really, really helpful for you. Your comments are always welcome. If you have any questions, let me know. If you haven't already subscribed, please subscribe. Thanks.